I actually think this is really an amazing and exciting time for Rett syndrome. There's are several ongoing or completed clinical trials in Rett that show promise and really offer hope for families um, and hope for modifying treatments. So I'll just talk about a couple that are, really in late stage clinical testing. So the one that many people are aware of is Arcadia and Neuron Pharmaceuticals have completed a late stage clinical trial with their leading compound, trofinetide, in Rett syndrome girls. And trofinetide, it's a synthetic analog of glycine proline, excuse me, glycine proline glutamate, or GPE, um, which is the N-terminal tripeptide of insulin-like growth factor. So it's believed that the neurotrophic properties of triphenotide are able to normalize neuronal and glial functioning. And so recently, as I mentioned, a late stage phase 3 randomized double blind placebo controlled trial was completed. And the results showed really, improvements across a range of symptom domains and in individual symptoms as well, which include improvements in repetitive behavior, improvements in breathing problems, mood abnormalities, ambulation, walking, and seizures. So that is, I think the company is now planning to, go back to the FDA to see if they can get approval for the drug. A second trial that's in still ongoing, but in late stage testing, is being run by Anavex Life Sciences, and their compound blarcamazine is a sigma 1 receptor agonist and muscarinic receptor modulator, which has been shown in preclinical studies able to restore cellular homeostasis and synaptic plasticity and increase the release of the neurotrophic factor BDNF. And so they completed a phase 2/3 controlled trial, and that trial met outcomes and showed statistically significant and clinically meaningful reduction in many of the Rett syndrome symptoms. And they are now conducting a clinical trial in pediatric patients. There are other treatment targets that are still in the preclinical stage of testing, and these include deep brain stimulation, and that's thought in preclinical animal models that's been shown to restore gene expression and improve many Rett syndromes, Rett symptoms in the mouse models. Ketamine, which is an NMDA receptor antagonist. There are some studies going on in valproic acid, which is a histone deacetylase inhibitor, which reactivates transcription of a wide variety of genes. One really, really exciting area, and I think Rett syndrome is in the forefront of making advancements, is in gene therapy, in replacement therapy using AAV vectors. Um, now, this is this is extremely exciting, but it poses gene therapy and Rett syndrome poses several challenges. First, the amount of the protein, the protein level must be regulated very closely. Too much MECP2 is causes problems, and of course, in Rett syndrome, too little causes problems. So, if we're going to move into gene therapy, we have to have vectors that can be regulated and deliver precise amounts of the protein to cells. The other challenge, and this is for all neurodevelopmental disorders involving gene therapy, is getting good delivery to areas of the brain that are affected in the disorder. So there are, though, two companies right now that I'm aware of that are moving forward in early clinical testing. So one company, Neurogene, has received FDA approval to launch an early phase exploratory clinical trial using an AAV vector to deliver MECP2, to the brain, and they're going to be using intracerebral ventricle injection starting with adults with Rett syndrome. And their vector can be regulated to deliver precise amounts of full-length MECP2 to the brain. So that's pretty exciting. And I believe that testing will begin in 2023 sometime. Tasha gene therapy is also launching early phase clinical testing, again using a regulated AAV vector to deliver MECP2 to the brain. And the Tasha, their candidate, they're going to begin testing in Canada in 2023. Um, but they do plan to submit an IND to the FDA fairly soon in 2023 to start conducting future clinical trials in the US. There are other gene therapy approaches that are potentially promising, and they're still in the preclinical stage of testing. And that includes reactivating the healthy silent copy of MECP2 on the inactive X chromosome using small molecule approaches to reactivate the healthy copy. There are several labs that are looking at genome editing or RNA editing. So I think, these approaches are very exciting. They have their challenges, but I think the field is really moving forward in very amazing ways.